This video is a basic geometry review for those who are taking the SAT or the ACT exam. And if you're taking a geometry final exam, you could benefit from this video too. So let's go over some common shapes and the formulas that you need to know. So let's say if we have a circle. I know my drawing is not that great, but let's work with it. And let's say that the radius of the circle is 5. Given the radius, what is the circumference of the circle, and also what is the area? The first formula you need to know, the circumference is 2 pi r. So therefore, it's going to be 2 pi times 5, which is 10 pi. So that's the exact answer. Sometimes you may need to put this in your calculator and get a decimal value. So you could use the fact that pi is about 3.1416. So this is going to be 31.416. So that's the circumference. Now what is the equation for the area of a circle? The area of a circle is pi r squared. So for this particular example, it's pi times 5 squared. 5 squared is 25, so the area is 25 pi. So 25 times pi, I'm going to use the exact value. As a decimal, that's 78.54. Now what about the diameter? If you know the radius of the circle, what is the diameter? So the radius is between the center of the circle and it touches any point on the circle. That's the radius. The diameter also passes through the center of the circle, but it's the distance from one edge of the circle all the way to the other edge, and it always has to pass through the center of the circle. If you have a line that touches 2 points in the circle but doesn't pass through the circle, the center of the circle that is, it's a chord. So this line, it touches these 2 points on the circle, but it doesn't pass the center of the circle, so that makes it a chord. But a diameter is between 2 points on the edge of the circle, and the diameter passes through the center of the circle. So make sure you know the difference between the diameter and the chord. The diameter is twice the value of the radius, it's 2r. So in this case, 2 times 5 is 10. So for a circle, these are the three main equations you need to know. The circumference, 2 pi r, the area, pi r squared, and the diameter is twice the length of the radius. Now the next shape that we're going to talk about is the square. So let's say that the side length of the square is 8. What is the area and what is the perimeter of the square? The area of a square is basically side squared. All sides of the square are the same. So in this case, S is 8. So the area is just going to be 8 squared, which is 64 square units. Now to find the perimeter is the sum of the 4 sides. It's S plus S plus S plus S. If you add S 4 times, it's the same as 4 times S. So the perimeter is 4 times 8, so it's 32 units long. So make sure you know those two equations for a square. The area is side squared. The perimeter is simply the sum of all 4 sides, or 4s. Now here's a question for you. Going back to the square, let's say the area is 36 square feet. What is the perimeter of the square? So we know that the area is s squared. By the way, for each of these questions, pause the video and see if you can figure it out. So the area is 36. If we take the square root of both sides, we can get the length of each side. So each side is 6 units long. Therefore, the perimeter is 6 plus 6 plus 6 plus 6 4 times, or 4 times 6. So it's 24 feet long. That's the perimeter. Now going back to the circle, let's say if we're given the circumference of the circle. Let's say the circumference is 16 pi. With this information, find the length of the diameter and also the area of the circle. So first, we need to find the radius. We know that the circumference is 2 pi r, and the circumference is 16 pi. So what we need to do is divide both sides by 2 pi. So 2 pi divided by 2 pi is 1. Here the pi's cancel. So the radius is 16 divided by 2, so it's 8 units long. If you have the radius, you can easily find the diameter. The radius is twice the length of the diameter, so it's 16 units. So now we can find the area, which is simply pi r squared. So it's pi times 8 squared, or simply 64 pi. So that's the area. Now let's say if you have a rectangle, and let's say the length of the rectangle is 10 and the width is 5. What is the area and what is the perimeter of the rectangle? Feel free to pause the video and find these two things. So this is the length, this is the width. This side is also the width and this is the length. The area is simply length times width. The perimeter is 2L plus 2W. So the area is going to be 10 times 5, so it's 50 square units. The perimeter is going to be 2 times 10 plus 2 times 5. 2 times 10 is 20, 2 times 5 is 10, 20 plus 10 is 30. So the perimeter is 30 units long, and the area is 50 square units. So let's say if the area is 40 units long, and let's say the length is 8 units. What is the perimeter of the rectangle? Go ahead and try that problem. So the length is 8. We don't know the width, but we could find the width by using this equation. So 40 is equal to 8 times W. So W is 40 divided by 8. So it's 5 units long. And then once you have the width, you can now find the perimeter. So it's going to be 2L plus 2W. So it's 2 times 8 plus 2 times 5. And that's 16 plus 10, which is 26. So here's a practice problem that you could try. So go ahead and take a minute and see if you can figure it out. The length of a rectangle is 3 more than twice the width. If the area is 44 square centimeters, what is the perimeter of the rectangle? So take a minute and work on that problem. So let's draw a picture. So this is the length, this is the width. Now let's write an equation. The length is 3 more, or 3 plus, twice the width. That's 2W. And we know the area is 44 square units. What is the perimeter of the rectangle? If we could find the length and the width, then we could find the perimeter. The area, we know it's length times width. And what we can do, if we want to, is we can replace L with 3 plus 2W. So we can get the area equation in terms of W alone. So we got to solve this by substitution. So 3 plus 2W times W is equal to 44. Now let's distribute W. So W times 3 is 3W. W times 2W is 2W squared. Now let's move the 44 from the left side to the right side. So 0 is equal to 2W squared plus 3W minus 44. So what we have is a trinomial, or a quadratic expression, and we need to factor it in order to find the value of W. So how can we factor this particular trinomial? What we need to do first is multiply the leading coefficient, which is 2, by the constant term, negative 44. 2 times negative 44 is negative 88. So what two numbers multiply to negative 88 but add to the middle coefficient 3? This is positive 11 and negative 8. 11 plus negative 8 adds up to 3, but they multiply to negative 88. So now what we're going to do is we're going to replace the middle term 3W with 11W and negative 8W. So it's going to be 0 is equal to 2W squared minus 8W plus 11W minus 44. I wanted to put the 11 next to the 44 because 44 is a multiple of 11, and 8 is a multiple of 2. So in the next step, we're going to factor by grouping. and that's why I've arranged it the way I did. So in the first two terms, let's take out the GCF. The greatest common factor is 2w. 2w squared divided by 2w, that's going to be w. Negative 8w divided by 2w is negative 4. In the last two terms, let's take out an 11. And let's get rid of some of this stuff over here. Actually, I'm going to need that. So let's just get rid of this. And I don't think I need this for now. So if we take out an 11, 11w divided by 11 is w. And negative 44 divided by 11, that's negative 4. So now let's factor w minus 4. When those two terms are the same, that means that you're on the right track. You've done everything correctly so far. So if we take out w minus 4 from this term, what we're going to have left over is the 2w. And if we take it out from the second term, we're going to have 11 left over, but it's going to be plus 11. So now what we need to do is set both factors, w minus 4 and 2w plus 11, equal to 0. So if we add 4 to both sides, we can see that w is equal to 4. In the other equation, we got to start by subtracting both sides by 11. So 2w is equal to negative 11. And if we divide by 2, w is negative 11 over 2. Now, we're going to get rid of the negative answer because we're dealing with a real-life object. And to have a side length of negative 5.5 doesn't make sense. So we're going to choose this value. W is equal to 4. So if w is 4, we can now find the length, which is 3 plus 2w, or 3 plus 2 times 4. So that's 3 plus 8, and that's 11. So the length is 11, and the width is 4. And we can see why the area is length times width, 4 times 11, which is 44. So that works out. Now we can find the perimeter. The perimeter is 2L plus 2W. So that's 2 times 11 plus 2 times 4. And so that's 22 plus 8, which is 30. So that's the answer to this particular problem. That's the perimeter of the rectangle. By the way, for those of you who are taking the ACT exam or the SAT exam, when you get a chance, go to YouTube and search out my ACT math video and SAT math video. You can get more examples and multiple choice practice problems if you want to practice and prepare for the math sections of those exams. I'm also going to post it at the last 20 seconds in the end of this video, so you could find the link there as well. Or you can just search it to YouTube, it should come up. But let's continue with this problem. The length of a rectangle is 3 more than its width. If the perimeter is 26, what is the area of the rectangle? So go ahead and try that problem. Now we know the perimeter is 2L plus 2W. So 26 is equal to 2L plus 2W. Now notice that we could simplify this equation. Let's divide everything by 2. So 13 is equal to L plus W. Our goal is to find the area of the rectangle. If we could find the dimensions, if we could find the length and the width, then we could easily find the area. Now we're told that the length is 3 more than its width. So L is 3 plus W. So what we're going to do at this point is replace L with 3 plus W. So 13 is equal to 3 plus W plus W. So that's 3 plus 2W. Now we can find the value of W. Let's subtract both sides by 3. So 10 is equal to 2W. And if we divide both sides by 2, 10 divided by 2 is 5. So W is 5. L is 3 more than W, so 3 plus 5 is 8. So L is 8. So we have the width and we have the length. Now we know that the area is length times width, or 8 times 5. So it's 40 square units, and that's the answer. Now let's talk about triangles. Let's say if we have a right triangle, and let's say one side, one of the legs is 3 and the other leg is 4. What is the hypotenuse of the triangle? Let's call the side A, B, and C. According to the Pythagorean theorem, a squared plus b squared is equal to c squared. So we can say a is 3, b is 4, and let's find c. 3 squared is 9, 4 squared is 16, and 9 plus 16 is 25. So if you take the square root of 25, this will give you 5. So the length of the hypotenuse, which is the side across the 90-degree angle, represented by this box, that is 5 units long. Let's try another example. Let's say the hypotenuse is 13 units long, and one of the legs is 5. Find the missing side. Now you need to know some special numbers for a right triangle. There's the 3, 4, 5 triangle. There's the 5, 12, 13 triangle, which is the one that we need. So notice that the missing side is 12. And some other ones that you need to know is the 7, 24, 25 triangle, the 8, 15, 17 triangle. There's the 9, 40, 41 triangle, and also the 11, 60, 61 triangle. So if you know these triangles, you don't have to use the Pythagorean theorem formula. You could just simply find the missing number. But let's confirm it using Pythagorean theorem. Let's prove that this is 12. So we know that a squared plus b squared is equal to c squared. And our goal, let's say we're looking for b. So a is 5, and the hypotenuse c is 13. 5 squared is 25. 13 squared, 13 times 13 is 169. And if we subtract both sides by 25, 169 minus 25 is 144. So now we got to take the square root of 144, which is 12. So it pays to know the special right triangles. Here's another example. So let's say that the hypotenuse is 10 and one of the sides is 6. What is the missing side? Go ahead and pause the video and figure it out. So let's write the special triangles: 3, 4, 5, 5, 12, 13, 8, 15, 17, and so forth. Notice that if we take the 3, 4, 5 triangle, and if we multiply everything by 2, notice what happens. We're going to get the 6, 8, 10 triangle. So multiples of the 3, 4, 5 triangle also apply to a right triangle. Here this is 6, this is 10, the missing number is 8, so x is 8. So let's prove that. So a squared plus b squared is equal to c squared. A is 6, we're looking for b, and the hypotenuse is 10. 6 squared is 36. 10 squared is 100. 100 minus 36 is 64. And the square root of 64 will give us the missing side, which is 8. So let me give you a few examples. For all of these, find the missing side. Find the value of x. You can get started with the first example. Okay, so let's start with the first one. The first one is associated with the 7, 24, 25 triangle. Therefore, x is 25. Now for the second one, it's associated with the 8, 15, 17 triangle. we have 15 and 17, so the missing side has to be 8. Now for the third one, notice that it's proportional to the 3, 4, 5 triangle. It's not proportional to any other right triangle. So if we multiply these numbers by 3, we're going to get 2 of the numbers that we have in the triangle. 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. So if you see 2 sides present, then you know the third side has to be 12. The next one is simply the 9, it's the 40. Actually, I messed up on this one. I meant this to be 9. It's supposed to be the 9, 40, 41, but I got mixed up with the 11, 60, 61, so that's a bad problem. Ignore it. Now the next one is associated with the 5, 12, 13 triangle. If we multiply those numbers by 2, it's going to be 5 times 2 is 10, 12 times 2 is 24, 13 times 2 is 26. So we have 2 of these numbers, 10 and 26. So the missing side has to be 24. Now for the last one, let me redraw it because of all the clutter. This is 30, 40, and we're looking for x. Notice that this is similar to the 3, 4, 5 triangle. So if we multiply 3 by 10, we get 30. 4 by 10, 40. So 5 times 10 is 50. So that hypotenuse is 50. Here's another problem that you could try. A rectangle ABCD, AB is 12 units long and AC is 13 units long. What is the area of the rectangle? Now rectangles, they form 90-degree angles. And look at the triangle that forms. We have a right triangle. If this is 12 and that's 13, what is the missing side? So we know this is the 5, 12, 13 triangle. So length BC is 5. So now we can find the area. The area of the rectangle is length times width. The length is 12, the width is 5. So it's just 12 times 5, which is 60. So as you can see, you can find the answer quickly if you know your special right triangles. You don't have to use the Pythagorean theorem formula. If you commit this to memory, it will save you a lot of time. And on the SAT test and on the ACT test, time is a factor. So you want to find the answer quickly.